So, shall we find out if this works? But before we do that, I just thought I would say, I was reading the comments from the last video, and I think some people perhaps misunderstand what this channel is about. Now, I'm not an educator, I'm like an experimenter. You are not entitled to the correct answer when you watch one of my videos. It doesn't mean I'm going to have it, or it also doesn't mean I'm going to come to the right conclusion. Now, I mentioned that I'm no good with maths, and I'm not. I don't really understand it. But I can do the basic application of maths. Someone said perhaps I should go back to primary school. A little bit mean-spirited, I think, but it just doesn't work in my head. I can't really see numbers. I get confused with it. And I try my best. I read a lot of the application notes for some wireless design stuff, but I just can't understand it. But I am going to try and learn some things about the design process that I can pick up and learn. I don't need to learn everything. That's not what I'm here for. And it's certainly not what you should be watching this channel for. So if you don't like it, don't watch it. That's what I'm saying. Anyway, we'll continue and we'll see if this experiment has paid off. So let's solder one of these up, shall we? Now we're going to need a diode. Let's have a look at the forward voltage drop on that. Oh, I've got some croc clips attached to this. It won't make any difference. Oh, other way around. 0.5 volts. So we're going to lose 0.5 volts. Oh well, we'll just have to deal with that. Just want to see if it works. I don't see why it shouldn't work, but it may well not work. Well, I guess. So we'll also need, what else do we need? We'll stick a capacitor on. We don't really need that. We could work it without that, but we'll pick one in a little bit. So the diode in this situation is rectifying the AC signal that we're getting in. We'll look at it on a scope actually, the AC signal. So once I've soldered up this diode and thrown a capacitor in, we'll look at the signal on the other side before it's rectified. And we'll see what kind of voltage we're getting from the transmitter that I've got, which is a dumb transmitter, not a QI one. So we'll also get some wires soldered on here so we can plug it into a breadboard so it's easier to measure. So where do they need to go? I haven't really got the right colours, but these ones will have to do. So they want to go right there. Actually, no, I'm not going to use my good snips just yet. Okay, let's choose a capacitor. I'm looking for something in the picofarad range, just because I've read that's what a lot of people use. I'm not even going to bother trying to figure out whether we're matching our resonance or anything like that. So we're on capacitance mode. And that's what? 0.1 nanofarad. That'll do. Let's get that in there. So just remember, this is an experiment. It is not a product I'm going to produce. The original idea was that it could be something cool to use as a shitty add-on thing, but that's not going to be the case in reality. I've just wasted some of my own money just to experiment with something that I've not done before. And I think that is okay. That is what we're on this earth for. Ow, my word, that was hot. Okay, good. Let's get the transmitter in. Okay, power supply is on. We've got 12 volts on this transmitter. I've got a breadboard over here and I've got an LED and a resistor, so let's throw that in the circuit. I've got a capacitor, I don't really need that just yet. Let's plug the power in and the ground, and we'll just turn it on and see what happens. Right, so the power supply is drawing 80 milliamps. Oh, okay, so we've got an LED on. Holy crap. Okay, it does seem like someone said in the comments of the last video, they said people think it's voodoo, but really it's just a transformer with an air gap. And that's fine, I get it, but it is voodoo, isn't it? I mean, look at it. So let's see if we can find the sweet spot. So my square here has the coil running like that. So if I make sure it's roughly in the center of that coil, that looks about right. In fact, we can tune it. No, the placement we can do with the multimeter. If we just plug it on to, I need one on power, so let's go there. So positive, we'll see what kind of voltage we're getting. So I'm reading minus 0.5 volts. That does not make sense. What have I done wrong? That isn't possible. We're lighting the LED. What am I doing wrong here? Well, we're getting 6 volts AC. Why am I not reading DC? Right, it's time to just probe the board, I think. Take the LED out of the equation for now. So I'm getting 2.5 volts. Right, let's put a capacitor in. I've only got a 2.2 microfarad one, but we'll throw it in. See if that gives us a nicer power rail. Whoops, let's cut those off. And we've got almost 4 volts there. Oh, there is 4 volts. Okay, now let's put that LED back into the circuit. And we drop a lot there. So 3.4 with an LED which is drawing very little current. In fact, we can find out how much. Let's do that. All right, that LED is drawing 1.5 milliamps. So someone said that we should look at shielding this with some ferrite material. So I'll grab that ferrite material. I'm just going to put this back onto volts measurement because I think that's where we're going to see a difference. Right, so 3.4, that's fine. Now this is that other coil. And if I just take off that ferrite material and pop it on this side, a very slight increase in voltage there. I mean, moving this doesn't actually help very much, but very, very slight. What's that, maybe 60 millivolts? What about a magnet? What will that do? Anything? I don't know, this is all experimentation at this point. Well, it's just going to mess around with the magnetic fields, isn't it? So I'm not sure that's ideal. How about the other charger? So remember I had this one as well. We can try this one out. Let's just turn the power supply off for now and bring this in. Now, I don't know whether this is a QI charger. It doesn't say it is, or if it's like QI compliant or whatever. So I don't know if it's going to work. Let's plug it into a power source. Well, it kind of works. So it's flashing. Now I'm going to have to sort of assume that that is, that's the communication protocol, isn't it? Let's put this capacitor in and see if we can get a better reading on that voltage. In fact, if I take the LED out of circuit for a second, just let that voltage build up, and then it'll give me some kind of indication here. 6 volts. Quickly collapsing. Now, I wonder if we can fool this thing. Where is... So these are QI compliant charger things, but maybe I can just throw it on. Whoops. Maybe I can just throw it on and confuse it to light all the time. Yes, I can, but that seems like quite a high voltage coming out there that I'm coupling onto. But take it away, is it still going to go? And no, it thinks there's no device there. Is it going to work again? Yeah. Is there a little LED over here? Oh yeah, can you see? I'm not sure that's focused, but we've got a little LED there. What happens when I put that on? Interesting. What happens when I put my crappy thingy on there? Just red. So that's the QI protocol, isn't it? What else can we bung on this thing? All right, let's try something else. I've got one of these things, USB lights and croc clips. So let's try that. Okay, so it's flashing away. So let's fool it again. Where is that thing? Ah, there it is. Hey! So my thing works, the coil works, but it has no QI protocol stuff on it. So I'm just going to get these communication flashes, it seems. Let's go back to the other coil. So that's not bad, is it? So I don't know whether it's about current draw or not. But that seems to be giving us a higher voltage now. Let's take out this capacitor. So now now we're getting 6.9 volts. Okay. Why? I wonder how far away we can get with this. Let's have a look. In fact, it's easier to show you sideways, isn't it? Maybe. Hang on. How are we getting 8 volts? Don't really understand this. So this one over here must have some kind of regulation on it because it kicks out 5 volts. So maybe that's why this one kicks out so much. So I could put an LDO on there. In fact, shall we? So we're going to throw an LDO. This one's in, oh, what is it? AMS 1117. It's not a particularly good 3-volt regulator, but it's what I've got. So let's just put the big tab on. I'm gonna need some tweezers. Hopefully I got the footprint right. Not a great job, but it's a job that's done. Right, power supply back on. And we'll plug it in back over here as well. So, LED's back on. We're looking at 6.84 volts. But we don't want to do that. We want to probe the regulator now. So, I can't remember on which pins on here 3.3 volts is. That's the other way around. There we go. We're getting 3.3 volts. I mean, that's not surprising, is it? It's just an LDO. But really, it's kind of incredible. I think that kind of makes this a success, doesn't it? Sort of. Well, it's been fun playing around with. I think I need to learn a bit more about it, maybe figure out how to do matched coils. And I'd love to learn how to make a transmitter now. That would be brilliant. Like, turns out making a receiver is not that difficult. You can just Forrest Gump your way through it, ham-fisted attempt at creating a circuit board, like throw any coil together, and as long as you've got a diode in there, and you're sort of rectifying half that wave coming in. Oh, we were gonna look at the scope. Let's do that. Hell, I don't know how to use my scope. So, what voltage are we getting? 2 volts per division. Let's go a bit. Ooh, we've got quite a lot going on there. I want to go the other way. So we have a frequency coming in here. Let's see if we can trigger on it. So, yeah, look at that. We've got 71 kilohertz, and actually that's the frequency that our transmitter is kicking out. But we've got a capacitor on there, so it's probably not quite such a wide swing. Let's now probe onto the coil before the transistor. Sorry, before the diode. So let's change our trigger. Whoa, okay. So 5 volts per division. So that's 16 volts. Well, would you look at that? So that's our incoming signal. There's a lot going on, but you can see that it's being pulsed at 71.85 kilohertz. So knowing the transmitting frequency, we can perhaps look at making sure our coil resonates with the same frequency. I don't really know how that works. I'm not sure I'm going to figure it out, but that's been fun. All right, I'll speak to you all next time.